And meanwhile, we will start the session here. Okay, good afternoon, everybody. As we know, we are here to discuss about the concept of the MATLAB. In the first slide, I would like to discuss why there is a need of such type of the language. As we have discussed in the inauguration session, that being an engineer, it's our duty to utilize the rules and regulations given by the mathematicians and scientists, either to design the new system or to maintain and enhance the existing system for the welfare of the society. And as we know, when we say the system is nothing but that one is a collection of the parts that works on a given input or the signal in order to get the desired output. And sometimes we say there is no need of any feedback, that is the system operates on the input and we can get here the desired output. But in some cases there is need of the auto regression, and for that purpose a feedback is required here. Now, as we know, in order to maintain the performance of the system and time to time the effectiveness of the system is required. When we say effectiveness is nothing but that is a function that depends upon the human skills, software and the hardware. When we define any system or when we are interested in order to design any system, first of all we look into the matter of the requirements. Requirements are nothing but they are the ideal conditions. So in order to design any system, first of all we will apply here the practical approaches in order to get the some constraints. Those are known as the specifications or determination of the parameters. And if we have decided here the parameters, then we have to decide which type of the system has to be designed, whether it is the static or the dynamic. Okay, so in order to decide here the system, that is whether it is the dynamic or the static system. If the system is static, it means there is no memory, there is no need of the memory. And if we are interested for the dynamic system, then there is a need of the memory. In order to, yeah, it's okay. So, in order to design the system here, the dynamic system, as we have discussed, the dynamic system has the memories. And now again, we will compare the performance of the two types of the system. One is the static, the second one is the dynamic. When we say static, without any memory, those systems are represented with the help of the polynomials. And if the system is dynamic, means memory is required. And for the purpose of the memory, either we can use here the capacitor or we can use here the flip-flop. Means the systems can be designed in either in the analog domain or in the digital domain. When we are in the analog domain and we are interested to develop the mathematical model, then that model is developed with the help of the differential equation. And when we are interested for the digital system, then that model becomes the set of the differential equation, or that may be a simple differential equation here. So here, after getting these equations, that is the differential and difference, we can say it is a model of the system that may be very simple, that may be very complex, and in between these two extremes here. Now, if we are interested for the difference type of the equation, that is the digital system, then difference equation is represented something like in this manner, having the yn minus k and xn minus k, where the xn is the input, xn means that is the discrete time input, yn is the output, and after processing we will get here the yn as the function of the two, having the two terms here. The one is the negative one and the second one is the positive term here. This is only due to the input and this is due to the feedback here. Now, if we are interested for the analog system, then that can be represented with the help of the here a differential equation that may be one-dimensional or the two-dimensional depending upon the situation or the requirement. Again, if we see here the mathematical model of the system, whether we are in the digital domain or if we are in the analog domain, then we will find it is nothing but this is a function of the operators, coefficients, and the signals, that is the present and the previous signal. Here are some past outputs also here. Now, if main role of the coefficients starts here, coefficients are nothing but they are the parameters which decide the performance of our system. Now, if these coefficients are fixed, that is, they are not changing with respect to time, then that type of the system is known as the LTI system, linear time invariant system. And if there is a need that the parameters are changing their values, means adaptive nature has to be adopted here, then that type of the system is named as the adaptive system. And the first one is known as the deterministic approach, and the second one is the stochastic approach here. Now, whatever is the type of the system, whether it is the LTI or it is the adaptive one, if we see, the both can be modeled by this type of the equation here. And if there is only the second term, this one, then that is known as the moving average, because it is nothing but it is like the summation of the sum values and multiplied by the sum coefficient. Like the example, if we have the three values 1, 2, 3 and we add them, then we can say 1 plus 2 plus 3, like the summation, and divided by 3. It is a coefficient here. But in the average, the coefficient is fixed 1 by 3, but here the coefficient is changing. That's why it is also known as the moving average. And there is an auto regression, that is whatever is the output that will be given as the input to the system. That's why this model, that is, if we consider both the terms here, that is known as the auto regressive model. And in total, we can say it is the ARMA model, auto regressive moving average model. Now, suppose this is a system and it is subjected to any impulse input, means it is excited by the impulse input here, then what will happen? If there is no feedback, that is the only second terms exist here, then we will get here some response, a settled response after certain duration. That's why it is known as the finite impulse response system. But in the second case, whatever is the response, that will be again considered as the input to the system, and the response will be settled by and it will take infinite time. So this is known as the infinite impulse response system. These are some abbreviated terms here used for the moving average, auto regressive, IIR, infinite impulse response, FIR system. So this is the background about the system. So whatever is our field, whether we belong to the mechanical engineering, civil engineering, chemical engineering, whatever is our field, first of all we have to develop the mathematical model, and then we have to decide the type of the system, whether that one is the deterministic or the adaptive one. And again we have to consider whether is there any need of the feedback or not. So after the decision of this mathematical model, there is a need of the analysis, and analysis must be done in both the domain, time domain as well as frequency domain. As we know, if the equations are the differential equation, that is we are in the analog domain, then for that purpose we use the Laplace transform, and equations are differential equation, then for that purpose we use the jet transform. And in the Laplace transform, when we apply the Laplace transform, it means that equation or that model becomes a function of the S, and in the jet transformation it becomes a function of the jet. And if we replace S by e to power j omega or Z by e to power j omega, and we neglect here the real portion because that is responsible only for the damping here, then we can say it is nothing but that represents here the frequency domain representation and named as the Fourier transformation. If this Fourier transformation is applied for the discrete type of the signal, then that is known as the DTFT. But when we apply Fourier transformation as an algorithm or as a system to the discrete signal, then what happens? Whatever is the output that has a function of the e to power j, something like that, and that nature of that function is the continuous. And if we are interested to process it digitally, then there is a requirement of the conversion of this information into the digital. So again, if the DTFT is sampled, that is the sampling is applied here, again discretization is applied to the DTFT, then this DTFT will be converted in the form of the DFT. Now again the DFT has the function having the e to power j, k, like omega, like that, where the j and k both are the integers starting from 1 to n minus 1, for the capital N will be the interval of the discrete time signal here. Then we will see that this function that is named as the Twiddle function, it has a nature of the periodicity and the symmetricity. And if we see here the complexity of our model, then it has that three types of the operator. One is the multiplication, the second one is the addition, here the addition, and the third one is the delay, that is related to the memory devices or the storage devices here. So in order to reduce the complexity, we can reduce the number of the multiplication and addition by exploiting the property of the symmetricity and the periodicity. Hence we can reduce the number of the addition and multiplication, and now our algorithm, whatever is the related to the DFT, becomes fast. That's why it is known as the Fourier first Fourier transformation. We are well aware with these type of the transformation, but whatever are these type of the Fourier transformation, they are suitable only for the stationary signal, not suitable for the non-stationary signal like the speech as we are discussing here. Because in the speech, what happens, there are so many range of the frequencies, but it is suitable only for a particular range of the particular value of the frequency. So it is not suitable for a range of the frequency. For that purpose, we use here the short time Fourier transformation. That is whatever is that time duration that is here broken into the smaller time interval, and then we apply here that Fourier transformation that is known as the STFT. Again, for that duration, it becomes the stationary. So for another purpose, we use here the WT, that is wavelet transformation, that use the scaling as well as the transformation. In this one, we can see the performance of any particular range of the frequency at a particular time. So these are the concepts which are used for the purpose of the analysis, and after analysis, we utilize here the approximations, and after the approximation, whatever is our algorithm, that is analyzed, and if we are getting here the satisfactory algorithm, that is the result, and after analysis is satisfactory, then we will move to the next point here. Till now, we have converted the information from the requirement, that is the ideal domain, to our mathematical domain, and then approximation, etc. But in this one, we have assumed that whatever is the information from one domain, it can be transferred into the another domain, but it's not true, because finite precision will take place here. For example, if we are interested in order to implement our algorithm on a particular processor, then word length of that processor will affect the performance of our system. Means here the coefficient as well as the signal, both will be stored or quantized according to the here the word length of that processor. So the quantization error takes place, and after quantization, again analysis is required here. And again, if we are getting here the satisfactory result, then for the purpose of the implementation may be either of the way, that is the software or the hardware implementation. For the purpose of the software implementation, we can write here the code, and for the hardware implementation, we can write the code, and that code can be downloaded on a given target, and then that target will be subjected to a real-time signal, and we will see here the performance of our design, developed, downloaded algorithm on a given target. So these are the concepts will be used in any branch of the engineering. Means first we think, and that idea is converted into mathematical model. It is analyzed, and then it is implemented either in the form hardware form or in the software form. Now the question arises, for these type of the analysis, these type of the mathematical modeling, similar here that these type of the different types of the approximation, quantization, there is a lot number of the equations and having a very large complexity. And in order to solve these problems, these complexity, we have to use such type of the language which is very easy for us. That is having the facility of the graphical user interface. That must be very interactive. That must be a computational language. And all the features are with this lab here, that is the MATLAB, Matrix Laboratory. That's why we have here to discuss about the concept of the MATLAB. In this one, what we are doing, we are just developing here the theoretical concept and the mathematical model, etc. here. And we have discussed in this one in the previous slide. But here I would like to discuss this concept here. During the quantization, what happens? If we see the previous equation, then in the previous equation, the system means algorithm or the set of the algorithms, or that is the equation or the set of the equations operates on the input signal, and then after operation we will get here the output. Now if the quantization takes place, then input will be quantized, and each and every coefficients will be quantized, and accordingly output will become quantized here. What is the multiplicand, that will be quantized, and product will be quantized, and sum will be also quantized here. So the quantization will take place at the different levels here. Now how the quantization is decided and how it will be included in our program. Now see, first we have to see what is the mode. And mode means either we have to use mode means which type of the number system has to be used in the, because whatever we are saying here, the machine will respond only the 0 and 1 binary numbers, not the concept and here the theoretical ideas. It will respond only the 0 and 1. So during the time of the conversion of our concept in the 0 and 1, we have to utilize the quantization concept, and during the quantization we have to decide the number system, whether that is the fixed point number system, floating point number system. And even if the floating point number system, then float, when we write only float, it means it is user defined. And there is a standard that is known as the IEEE 754 standard, having the two types of the precision. One is the single precision having the 32-bit word length, and the second one is the double precision having the 64-bit word length. And if we consider this here the mode, it means which type of the number system has to be used, then next step is the round mode. Which type of the rounding has to be applied here, means whether ceiling, that is towards the plus infinity, or the convergent, fixed, floor towards the negative, minus infinity, etc. Here round, there are the 5 modes of the approximation or the truncation which has to be used here during the time of the quantization. And due to this quantization, overflow or the underflow will take place, and we have to also take the care of this overflow, and we have to decide the mode of the overflow, whether that one is the saturation one or the wrap one. And we have to decide the data format, that is what is the total word length, capital N and small n. This is the format for the fixed point number system, that is the total word length of the of that system, and small n is the number of the bits that will be utilized to represent the here the integers here. Similarly, here the total word length and E will represent the number of the bits that will represent the exponents of the floating point number system. So we have discussed in this one that as we have discussed in the previous slide, that first we will understand the problem, then we will design the algorithm implementable that will be converted into the implementable form, and then efficient algorithm will be designed. And through the IDE, and particularly here we are using the CCS Code Composer Studio, it is nothing but this is the IDE integrated development environment. These are the steps which will be used in order to design our algorithm, and that algorithm has to be downloaded on a given target. Here suppose this is a particular processor having the interface, different type of the interfaces, so that we can interact with the real world, and we are interested to download this concept on this given target here, and for that purpose we will use here the IDE. Now for example, say this IDE accept only the .c file. So if we have written any program, either it is the .mdl or this is written with the help of the toolbox, we have developed it with the help of the toolbox, then first of all that will be converted into the .c using the real-time workshop. So this is just describes the concept what we have to do. First we have to develop the implementable algorithm, then that with the help of the IDE that will be downloaded to the given target, and then here we will apply here the real life signal, and we will see the response of that system, means how our algorithm is working. When we download our concept on a given processor, so whatever are the resources of that processor, they are arranged according to our algorithm here. So this is the having the flexible connectivity, and that will be programmed as per our algorithm here. This is the concept. That's why we are moving towards a language that is known as the MATLAB. As we have discussed, the advantages of the MATLAB: easy to program, similar to other languages such as the C, highly integrated with the better expansion capability, and powerful numerical methods for various math problems, symbolic computation, and here the numerous toolboxes in different math, engineering, and non-engineering fields. Powerful dynamic system simulation that can be used with the help of the MATLAB, graphical user interface based simulation modeling here, and powerful language in automatic control that can be used in the automatic control system here. And as we know, in daily life we can use the MATLAB for the purpose of the automobiles, in the field of the communication, in the field of the aerospace, data analysis, finance, etc. There are the engineering or the non-engineering fields where we can use the MATLAB here. And in today's lecture, all participants are requested again I am requesting with you that we have to learn here something. I will learn from yourself, and you try to be connected with me. I will try to deliver each and everything starting from the very basic level, that is from very beginning, that is the 0 here. And we will, in this lecture, we will discuss the different type of the commands, and we will see how the one word, that is one command, is capable to perform a particular type of the performance here, that may be said like a particular type of the program here. Now, for the purpose of the installing, you can use here the compiler, and either you can see here the MathsWork website, or you can mail to the MathsWork on this email here. And now see, if we see the construction of the MATLAB, then its main kernel is the C kernel, and with the help of these C kernels, we use the commands, and with the help of the commands, we write a program that is named as the .m file. And for a particular field of the application, we use the toolboxes like in the signal processing, control system engineering, and the next one is the Simulink. Simulink describes a model of a system. That is, if we have designed any model, then that model will be discussed with the help of the Simulink here. When we will click the icon of this MATLAB, then we will find here the three main windows, that is the command window, workspace, and the command history here. And in the command window, we have to type the command. And now see here, this is the on your monitor, you will see this type of the dialog box when you will click on a icon of the MATLAB. And here, philosophy of the data storage, as we know, these are the philosophy, that is the numerical values, either in the form of the integers, floating points, complex, character strings, or that may be a structure here, or that may be cells here, Boolean form, that is the logical operation, true and false. And we will discuss here now we are just starting here the commands. See, nothing is special. I'm again repeating, nothing is special during the time of the learning of the commands or the program of the MATLAB. Whatever we use in our daily life, the same has to be used in the programming also. Here, see, assignment will be given by this symbol, as we used to use this one here. X is the variable that is assigned by 1 here, the Y is this one. And after assigning addition, we will use this one, and the Z is a next new vector that has that will depend upon the X and Y. And after addition, we will get the value of that function Z here. And similarly for the subtraction here. And now if we are interested for the multiplication, these are all related to the scalar quantities. I'm repeating it for the scalar quantities because X has the value of the 1, Y has this one. And if for the purpose of the multiplication, whatever is the value of the Y, that will be multiplied by the 2, and hence we will get a new value of the Z here. Similarly, for the division, we will use the backslash here. For the power, we will use this cap sign here, and 5 to the power 3, that is the 125, will be written here. And now, if we again see some scalar additions here, this is the same. X is the value given value in the previous slide, and addition of the 2, we will get here the new vector Z. Here, if we are interested in order to write any matrix, then any row will be terminated by the semicolon, and elements of a particular row will be separated by either a space or by a character here, comma, like a character here. For the purpose of the subtraction, we use this symbol here, and similarly for the multiplication, again we will use the same symbol here. Now for the division, same. Now here for the purpose of the summation, when we are interested to sum all the elements of a particular vector, then we use this summation of the xi are the elements of the vector x starting from 1 to n, and this can be done only by writing the sum of the x. Means first we have to define the x. X is a row vector, that is the 1, 2, 3, and 4. It is a row vector having the here the characters 1, 2, 3, and 4, and they are separated by the comma here. We can use here the gap space also here. So sum of the x will become the summation of all the elements, and we will get here the 10. Similarly, in order to get the product of the elements, and during the time of the to getting the product, we will use here the column matrix. That is the 1 semicolon, that is the next row we will start here, 2 semicolon, next row, and so on. So, and if we write here the product of the y, here the elements, all the elements will be multiplied, and the product will be displayed here as the 24. Now, if we again see here the inner product, that is the, if we say this is the row and this is a column, and if we multiply it, then element wise operation, that first will be multiplied by this first one, x1 y1 plus x2 y2, like that. Here the summation of the xi, yi. This is the mathematical representation of the inner product, and same can be done with the help of this one here. That first we will define the two vectors x and y, and we will put here the multiplication sign, that is asterisk. And one thing has to be noted here, that the row and column both must have the same number of the elements, as we know. So here we will get here the x multiplied by y, and we will get here the net result here. That is the summation of all the products here, and finally we will get here the 14 as the output here. Similarly, if we are interested in order to transpose any matrix, then we just consider here the matrix and we write here the transpose of the matrix, and we know a long procedure has to be adopted in order to get the transpose of the matrix. But in MATLAB, first define the vector x and then write here the x from here, and we will get here the transpose of that matrix. That is, the rows will be changed into the column like that. Cross product, that is the vector product here. The two vectors are the x and y are given here, and if we are interested to get the cross product, then we have to just put here the cross. Nothing is special. Whatever we use, the same has to be utilized here. The same concept, same word has to be used here. So here the very basic concepts has to be adapted here. And now we are moving to a new concept, that is the vector operators here. Now in the vector operators, if we have the two vectors x and y, for the purpose of the addition, we will use the same sign, x plus y, and we will get the result. And similarly for the subtraction, multiplication. Now one thing has to be noted here. Suppose we have the two vectors, then during the time of the multiplication, we can use the dot and then operator. And here we will get here the result, that is the element wise of multiplication will take place, and we will get here the row matrix. Similarly for the division, we will use the dot and then black slice, and for the power, dot and here the cap sign. Now suppose we are interested in order to display any matrix having a row matrix, then it can be represented. V is a vector that has a row elements 1, 2, 4, 5, and here this is the value here. This can be entered in the MATLAB like in this manner, that is the characters will be here the separated by a comma, or one space may be also utilized here, and this is a row vector here. Similarly, if we are interested for a column matrix, in order to represent the column matrix here, then we can use here the semicolon. That is, the first row terminates, second row starts, again terminates, and like that. And this will be the represented here the column matrix here. Now, if we are interested for the two-dimensional array, that is the rows and columns, suppose this matrix has to be entered, then for the purpose of the entry of this matrix, or to represent this type of the matrix, we will write here the first row, that is the 1, 2, 3, and then terminate this one, semicolon, and it starts the new row and the last one. So these are the representation of the matrices. And if we are interested in order to indexing the matrix here, say if we write here the A23 means second row, third column. So this is the second row and the third column. So the element 6 will be selected here. Similarly, if we write here the A23, that is the second and the third row. So this is the second row and this is the third row, first and second column. So the first column and the second column. So the common elements will be the 4, -5, 5, and 6. This will be the index here. Similarly, and one more thing has to be noted here, that the ordering of the indices is important here, and MATLAB is also case sensitive. So here, if we write here the B, a new vector, say B, and here we have changed the ordering, that is the 3, 2, and 2, 1, then we will get here the different result here. Now, indexing a particular row, A1, then column, that is the first row will be selected, 1 and 2, both rows will be selected here, and same can be represented here by this command also here. If we are interested in order to represent any matrix, suppose the first element is 1 and the last element is 5, then if we write this type of the command, that is 1, 5, means here the gap of the 1. By default, the gap will be considered 1. Now, if we are interested to write the same values, that is 1 to 5, but having a gap of the 2, then we will write it the 1, 2, last value. That is the initial value, colon, the step size, colon, then the final value. And here we see that the two vectors, both are starting from 1 and the last one is 5, but this is by default having a gap of the 1 and this has a gap of the 2, which we have selected. So we can select a gap of the gap between the two consecutive elements here. Similarly, as we have discussed the previous commands, suppose we are interested in order to get the mean of any vector, just write here the mean of a. The result will return in the mean of A. For example, we have considered this one here, and C max of A. This will here return the largest element of the vector A. And if we write the D comma N in parentheses here, maximum of A means the D is the largest element and N is the position. Here, if we see, then we will find what is the largest value and what is the position. For example, here the 9 is the largest value and its position is the 2. So, and for the sum of the A, we have discussed this one. All the elements will be summed here. Sort of A, arrange the elements in ascending order. Similarly, the median of the A, this will return the median value of the vector. Very simple. Whatever we use, the same can be here written during the time of the writing of the program as a command. Standard deviation, STDA, determinant, DET, inverse of any vector or the matrix A, inverse of I and V, and dot product, DOT of the two vectors and cross product of the two vectors by the cross here. There is one more thing during the time of the designing, that we have to introduce some random numbers here, like the noise or unwanted disturbances. And these noise or unwanted disturbances are modeled with the help of the random number. So in order to generate the random number, we have to use these commands here. If we write here the R, A, and D, it will generate the single random number between the 0 and 1. And if we write the random in parentheses 1 comma n, means it will generate the n numbers, random numbers, and having the values of between the 0 and 1, and this will be a row vector here. This is the example here. If we write here the random of the n, that will generate the n cross n, here the matrix, just moving, yeah, n cross n matrix will be generated here, and numbers will be naturally between the 0 and 1. And if we write the random m n, it means m cross n matrix will be generated here. And this is the example here of the 2 cross 4. And if we write the random per n, it will generate a row vector with a n elements that are permutations of integers 1 through n. If we write here the rand n, now see here that there are the two commands, one with the parenthesis and without parenthesis. If we write here the with the parenthesis, then n cross n matrix will be generated. And if we write here this rand n, that generates normally distributed numbers with means of 0 and standard deviation of the 1. That is very useful in the communication in order to modeling the concept of the noise. As we have discussed, that the numerical values may be represented with the help of the floating point having the single and the double precision. And in the integer, and during the time of the decision, whether we have to use the single precision or the double precision, we can write here the single or the double as in the command. Similarly, for the integers, we can write here the UINT, that is the unsigned integer having the word length of the 8 bit. Unsigned and similarly we write here the integer, that is the here the signed integer have the 8 bit, 16 bit, 32 bit, and unsigned integer 16 bit and the 32 bit. These are the very simple command. Nothing is special, nothing is complex. We know each and everything. Suppose we have the each and every connection, we have to just put on our switch here. Logical of variables, the ending of the A and B, ORing of the that is the here, as we know, ending is represented by this one, ORing any one of these two information, not of just inverse of this one, and X ORing, that is the XR command. Whatever is the name, same will be used in the command also here. And again, for the purpose of the truncation, we can use the different type of the operation here. For the flooring, we will write here the floor of this one, ceiling, rounding, fixing, rest. Here this is the this is the remainder after the division, REM, and this is the returns to the, this one is the GCD, and this is the LCM, factorization, and whether it is prime number or not. For these purposes, we just use here the command, that is the sealing for seal, rounding, fixing, whatever is the type of the rounding or the truncation. Accordingly, we will use here the command here. Now we are moving to the order of the precedences. Now the first order is the parenthesis, second is the exponentiation, the third is the logical NOT, fourth is the multiplication and the division having the same precedence, fifth one is the addition and subtraction, sixth is the relational operators, and the seventh one is the logical and eighth one is the logical OR. And so far we have discussed the basic concepts about the numerical values. But during the time of the analysis, there is a need of the graphical representation. Means whatever we have done in the calculative manner, means in numerical form or the number form, the same has to be represented graphically, so that we can analyze it more easy way. So now we are